Let's put all of this EKG into practice. So you have your EKG notes here. All right, now let's try to see what happens when this normal sinus rhythm goes wrong. All right, so the first thing we have is, in order to do that, we need to learn a little bit more about the EKG vocabulary. Okay, so the first thing is I need you guys to define, you're gonna take new notes and title this EKG and cardiac vocabulary. Okay, pause the video and do that now. Next up, I need you to research what EKG means. So EKG, go ahead and find that definition online. Then you're going to go into, what does a normal sinus rhythm mean? So you can kind of see it on my next paper. We have an abnormal sinus rhythm. What is a sinus rhythm? And then sinoatrial node. Give me a quick definition of what that is. It's also called the SA node for short, and that's our pacemaker of the heart. Then we go into our atrioventricular node, or the AV node for short. That middle one between the atria and the ventricles. And then you're going to jump into, what is the bundle of His? And then jump into the Purkinje fibers. And you should have a left branch and a right branch that squeezes both sides of the ventricles. What does it mean when somebody is tachycardic? Tachycardia. And I will tell you this right now. So that's TACHY. Is a Y. This means when something is too high or abnormally high. We have an abnormally high heart rate. Conversely, we have, sorry, we're in the train. Conversely, we have bradycardia, and this means when something is below average. So the heart's beating abnormally low. And then from there, what does it mean when the heart is going through something called a fibrillation, when it's fibrillating too fast? And when we can fix that in the hospital or in the pre-hospital settings, sorry, we have an automated external defibrillator. And from there, this is a device that is used to shock the rhythm, but we can only shock certain rhythms. So which rhythms can we shock? Not all rhythms can be shocked. For example, when somebody is flatlining, you can't shock that. A flatline is only CPR. You can only pump the heart. The heart's not beating at all. Therefore, we need to do CPR. Now, certain fibrillations, when the ventricles or atria is doing this, we can shock that. That's kind of like plugging your computer, turning the heart on and off again. We can also do that with certain drugs like amiodarone and adenosine. So I want you guys to find out what are shockable rhythms, and you're going to need to know that when we do our CPR training. All right. So that is your cardiac vocabulary. Now let's jump into some EKG readings. On the next page, and please pause here when you need to, I need you to write down on the next page EKG readings. Okay, so from here, the first reading you're going to have is a normal reading. We call this normal sinus rhythm. Okay, and then from here, I know, sorry, it doesn't look very normal. I'm so sorry about all these announcements. We're heading to the Bay Area to go see a doctor. Okay. Sorry about that. So normal sinus rhythm, we have the atria. That's going to be the P wave. And then we have the QRS wave, which is going, or complex. And that's going to be for the atria and the ventricles. And then we should have a nice little relax, and then this kind of final like clap right here where the ventricles kind of clap back. That T segment right there, that T wave. And then we should get a little bit of a break, and then we should go P, QRS, T. P, QRS, T. P, QRS, T. And that's normal rhythm. Okay, this is normal. The heart is happy when it's doing that. And obviously this whole PQRST is going to speed up when you're running. These segments are going to get a little shorter, okay, but you should have relax, recover, contract, contract, relax, okay? They're going to get a little closer together when you're running, and it might even get more spaced out when you're sleeping. But this is about normal. Now, this could be like 60 beats a minute. This could be 100 beats a minute, anywhere between that. We're going to be doing 60 to 100 beats per minute, okay? And this is normal. Abnormal, the first one we're going to see is abnormal when the atria is not contracting. And this is when we're going to get into what's called a heart block. For some reason, this sinus node is blocked. And as you can see here, this segment right here, this is normal. And then, what do you guys see? Absence of atrial contraction. So atria is not contracting, but the ventricles are. Atria not contracting, but the ventricles are. Okay, so it could be a sinus rhythm thing. It could be, or a sinoatrial valve node. This could be happening for whatever reason. For whatever reason, the heart is failing right here. But the ventricles will still contract. They're still electrically conducted. So no atria, ventricle. No atria, ventricle contraction. So this is a heart block of some kind. So on your test, what you might see is I might say, what's wrong with this rhythm? And you're going to have to tell me what's wrong here, okay? And you should see that absence of a P wave. So we call this absence of P wave, okay? And then we're going to jump into abnormal rhythms at the ventricles, okay? So here, and this is what we call a fibrillating. Nice view right there from the train window. Kind of cool. All right, so here you might have a, from here, we have the atria contracting, and then the ventricles start to quiver. Okay, so we get ventricular quivering, and then we get the atria again, atria contraction, and then the ventricles start to quiver. Okay, abnormal rhythm. Okay, this is fibrillation. This is a shockable rhythm, by the way. We can shock this. This might require an implantable pacemaker. This we can shock. This is abnormal. We would shock this. So that's abnormal ventricles. Another abnormal rhythm you might see is the atria fibrillating, also shockable. Now I see 99% of the time when I see a patient that has AFib, okay, we shorten this and we call it AFib, atrial fibrillation, they've also had a stroke or they're on medication to prevent a stroke. This is a stroke risk majorly here. I would say 9.5 times out of 10, when I see someone with AFib, they've either had a stroke or they're on medication to prevent a stroke. And if they've had a stroke, 100% of the time, they also have AFib, is what I have seen, unless there's another, the only time I haven't seen this correlation here is with a really young patient that threw a stroke for another reason. So here you can see that atria, the P wave, is quivering as in it's shaking, okay? But we have a normal QRS complex, okay? So the ventricles are doing just fine, but the atria, quiver, maybe it's not filling up with blood, and then the reason why it's a stroke risk is because, well, that's gonna back up, if you remember, going back to this, that's going to back up into the vena cavas, and this vena cava is coming right from the brain, so it's filling up with blood. It's not getting enough blood passed down. When blood sits, what does it do? It clots. So some of these clots might travel back up, or that clot is going to travel through and cause a pulmonary embolism in the lungs. Or if it does go through, what's one of the first stops? Well, the brain, brachiocephalic. Okay, so that's how you get a stroke risk. Remember, a stroke is like a heart attack in the brain. Okay, so that's it. Hopefully this helps.